Most beginners solve array problems by checking the same numbers again and again. It works, but it is slow. Watch what happens. Window after window, recalculating everything, the screen fills up with repeated work. Sliding window fixes this with one idea. Don't start over, reuse the previous window. That single trick turns a slow solution into a fast one. Let me show you exactly how. First, what even is a window? A window is just the part of the array we are currently looking at. Here is our array. This blue box around 3 numbers, that's the window. In sliding window, this box moves across the array, one step at a time, while we update our answer. That's it. The window is just the current range. The window is. Let's solve a classic. Find the maximum sum of any subarray of size k. Here k is 3, so every window must contain exactly 3 numbers. The size never changes. That makes this a fixed window. We slide a box of size 3 across the array and track the biggest sum we see. The brute force way is to build every window from scratch. 2 plus 1 plus 5 is 8, then 1 plus 5 plus 1 is 7, then 5 plus 1 plus 3 is 9. It works, but look closely. The 1 and the 5, we just added them. Now we're adding them again and again. We keep recalculating numbers we already used. For a big array, that wasted work piles up into O of n times k time. Here's the trick. When the window slides, most of the numbers stay the same. So we don't recalculate everything. Instead, we remove the number leaving on the left and add the new number entering on the right. Old sum was 8. The 2 leaves in red. A new one enters in green. 8 minus 2 plus 1 equals 7. New sum, 1 subtraction, 1 addition. Remove left. Add right. Reuse the previous sum. Here's the code. First, we build the very first window with 1 sum. Then for every next position, we add the value entering on the right and subtract the value falling off on the left. After each slide, we update our best answer. Notice the pattern. Add right, remove left, update. That's the whole fixed window. And the same idea works in Java, just different syntax, same 3 moves. So why is this faster? Brute force rebuilds every window, touching the same numbers over and over. Sliding window touches each element at most twice. Once when it enters, once when it leaves. That drops us from O of n squared down to O of n. One clean pass instead of nested loops. Quick recap for fixed windows. Build the first window, slide 1 step. Remove left, add right. Update the answer. Fixed window means the size never changes. Quick check before we move on. When the window slides right, what changes? Do we recalculate everything or just remove left and add right? It's B. Remove left, add right. If that clicked, the hard part is behind you. But fixed windows are only half the story. Not every problem hands you a size. Sometimes the window has to grow and shrink depending on a condition. Watch the difference. The fixed window keeps the same width. The variable window stretches and tightens. Now the size can change. And this is where most beginners get confused, so let's slow down. Here's a famous one, the longest substring without repeating characters. Take the string A, B, C, A, B, C, B, B. We want the longest window where every character appears only once. Our window starts empty, and we keep a set of the characters currently inside it. As the window moves, that set tells us if we've seen a character before. The rule is simple. If the window is valid, expand to the right. If the window becomes invalid, shrink from the left until it's valid again. Watch. Right pointer adds A, then B, then C. The window ABC is valid, all unique glowing green. Now the next character is A again. Duplicate. The window flashes red, so which pointer should move? The left one. We shrink from the left until that duplicate is gone, and the window turns green again. Expand when valid, shrink when invalid. Now the code slowly. The set holds the characters currently inside the window. Left and right mark its edges. For each new character on the right, while it's already in the set, we remove the leftmost character and move left forward. We keep shrinking until the duplicate is gone. Then we add the new character and update our best length, which is right minus left plus 1. Watch the pointers. Right expands. When a duplicate appears, left repairs. Notice we used while, not if, because we may need to shrink more than once. Same idea in Java with a hash set. Different syntax, identical logic. Here's a mental model that makes this stick. Think of the window like a rubber band over the string. The right pointer stretches it, reaching for more. The left pointer tightens it the moment the rule breaks. Right expands. Left repairs. Say it with me. Expand when valid, shrink when invalid. That one sentence is the entire variable window. Let's lock this in with one more example, a real interview favorite. Find the longest substring with at most k distinct characters. Here's the string E, C, E, B, A with k equal to 2. So the window may hold at most 2 different letters at once. Same expand and shrink rhythm, but now we track a count of each character inside the window. Expand right, E, then C, 2 distinct, still valid. Expand again to another E, it's already counted, so we still have just 2 distinct. The window ECE is valid, length 3. Now expand to B, that's 3 distinct letters, 1 too many. Invalid, so we shrink from the left, dropping characters until we're back to 2 distinct. The longest valid window we ever saw was length 3. Now the code, and notice how familiar it looks. A dictionary counts the characters currently inside the window. The right pointer adds each new character. Then the key part. While the number of distinct characters is greater than k, we shrink from the left, lowering counts, and when a count hits 0, that character leaves the window completely. After shrinking, we update the best length. That's it. It's the exact same expand and shrink engine from the previous problem. The only thing that changed was the rule for when a window is valid, at most k distinct characters. And that's the real takeaway. Once you can clearly state when a window is valid, almost every variable window problem collapses into this very same pattern. So how does this connect to 2-pointers? Sliding window is actually a special kind of 2-pointers. With general 2-pointers, like finding a pair that sums to a target, the 2-pointers often move toward each other from opposite ends. With sliding window, left and right move the same direction, and together they frame a continuous range. Sliding window uses 2-pointers to track a range. Now the mistakes that trip up beginners. 1. Using if instead of while, when, shrinking. If the window needs to shrink several times, a single if won't cut it. Watch, the if version leaves a duplicate behind. The while version keeps going until it's truly valid. 2. Updating your best answer at the wrong moment, before the window is even valid. 3. Moving both pointers with no clear rule. Always know why each pointer moves. How do you spot a sliding window problem in an interview? Listen for these words. Subarray, substring, longest, shortest, maximum sum. At most k, no repeats. Whenever a problem asks about a contiguous range and a condition inside it, your instinct should be, this might be sliding window. Look for a continuous range. Let's bring it all together. Sliding window means reuse the previous window. Fixed window, the size stays the same, so remove left and add right. Variable window, the size changes, so expand when valid and shrink when invalid. And in most cases, this turns repeated brute force work into one clean O of NPass. Reuse, slide, update. If sliding window finally clicked, comment the word window below. I read them. Next, we'll use this exact pattern to crack real interview problems, step by step. Subscribe to Code Clarity DSA for visual explanations that make algorithms finally make sense. See you in the next one.